Good evening and happy Thursday. We're getting towards the end already. We will now look at our final unit, analytic trigonometry. The vast majority of what we're going to be doing in this unit is identities, specifically deriving certain important identities. We'll be doing some product, some identities. Some difference identities, double angle identities, half angle identities, reduction identities. Those are on the docket for Wednesday. Then on Thursday, we'll do sum to product and product to sum identities, as well as looking at trigonometric equations, solving trigonometric equations. What we're going to be doing this evening is just verifying identities using the basic properties that we already know. And what are those properties? Well, we have, remember we saw the cofunction. Right, sine of pi over 2 minus theta is cosine of theta. Cosine of pi over 2 minus theta is sine of theta. Those are the two big ones. We also have similar identities for tangent, cotangent, and secant, cosecant. Let's do this. We also have the Pythagorean identities. There are three of them. Sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared. One plus cotangent squared is equal to cosecant squared. Right, we have even and odd. Cosine is even, sine is odd. And then we have the identities that allow us to write everything in terms of just sine and cosine. And that is just terrible. That's better. So again, I would recommend you have these written down on a reference sheet. Just see if I missed any. Okay, so the only other identities it looks like that I'm missing are the periodic identities. Okay. So as I said, what we're going to do with these problems is we're going to verify each of the given identities. What this boils down to, right? You start with one side of the equation, and then you use known identities to get to the other side. It doesn't matter which side you start with. Right, so generally speaking, working in one direction is going to be more obvious. The steps are more obvious than working in the other direction. You usually can't see that until you actually start working. I generally work left to right. So I'm going to start with the left-hand side and work my way to the right-hand side. So when in doubt, write everything in terms of sines and cosines. Secant squared. So secant we can write as 1 over cosine, right? That means secant squared would be 1 over cosine squared. And since cosecant is 1 over sine, we can write cosecant squared as 1 over sine squared. Right, now how do we take the product of fractions? We just multiply straight across. So we right now have 1 over cosine squared times sine squared. Huh. Right, you may be stuck on what to do at this point. Right, so if you get stuck, try working in the other direction. However, with enough practice at this, when you do this enough times, you start to see the little tricks. So I ultimately know I want to get to this. Right, which is 1 over cosine squared plus 1 over sine squared. Isn't 1 sine squared plus cosine squared? So we replace 1 with sine squared plus cosine squared. We can split this now into two fractions. Well, this first fraction, you have sine squared over sine squared, which is just 1. That simplifies down to 1 over cosine squared. The second fraction, you have a cosine squared over cosine squared, which is also just 1. One over cosine is secant, 1 over sine is cosecant. We can write that then as secant squared plus cosecant squared. And the identity's been verified. Okay. Now I want to verify secant to the fourth minus secant squared is equal to tangent to the fourth plus tangent squared. And again, your first order of business is to pick a side. I'm going to start with secant to the fourth minus secant squared. And let's see what we can do. Well, we can factor out a secant squared, right? Be left with secant squared minus 1. There's a Pythagorean identity that relates tangent squared and secant squared. So secant squared is tangent squared plus 1. So that's what this secant squared is going to become. This secant squared minus 1 becomes tangent squared. Now distribute that tangent squared through. You get tangent to the fourth plus tangent squared. And so the identity is verified. 2 cosecant of x equals sine of x over 1 plus cosine plus 1 plus cosine over sine. Let's start with 2 cosecant. That's going to be 2 over sine. Now, two things you can always do. You can always add 0 or multiply 1. Well, I noticed that I'm going to want a 1 plus cosine of x in the denominator as well. So let's multiply both numerator and denominator by 1 plus cosine. This looks troublesome. Isn't 2 1 plus 1? And one of these ones let's write it as sine squared plus cosine squared. Let's write this as two separate fractions. Sine squared over sine times 1 plus cosine. And then the remaining terms over sine times 1 plus cosine. Well, looky here, this first term is going to be a sine common in both numerator and denominator. We can write that as sine over 1 plus cosine. Which, look, is one of the terms we wanted. But now look at the second term. Specifically, look at the numerator. Can we simplify that numerator in any way? Wasn't that numerator quadratic? So we'd be able to write it. As a perfect square binomial, right? It's cosine of x plus 1 all squared. I'm going to grab that. Down. Since addition is commutative, you can switch the order. And now look, there is a 1 plus cosine x factor common in both the numerator and the denominator. What we're left with is sine over 1 plus cosine plus 1 plus cosine over sine. Hence, the identity is verified. Right now, you should notice that if you started with the right-hand side, oh, for Pete's sake. Let's try that again. If you start, excuse me, with the right-hand side, right, you starting here, right? Now just work backwards. Right, the other thing that wouldn't be included would be what's in orange. Right, so in this case, right, starting with the right-hand side made each step way more obvious on what you had to do. Right. Now to verify 1 minus sine over cosine equals cosine over 1 plus sine. Okay, so let's start with the left-hand side. Remember, we can multiply by 1. So let's try multiplying both numerator and denominator by 1 plus sine. The numerator. It's the difference of squares now, right? 1 minus sine squared. Isn't it cosine squared, right, by the Pythagorean identity? Right, then you have cosine squared over cosine, common factor of cosine. Then we get cosine over 1 plus sine. Which verifies the identity. Secant of A minus cosecant of A over secant of A plus cosecant of A. We're going to show that that equals tangent A minus 1 over tangent A plus 1. I don't know why I did that. That's what I want to show. Okay. Let's write everything in terms of sine and cosine. Right, so remember, secant is 1 over cosine. Cosecant is 1 over sine. Simplify both the numerator and the denominator. Numerator becomes sine A minus cosine A all over cosine A times sine A. Denominator becomes sine A plus cosine A all over cosine A times sine A. right? When you divide fractions, right, the rule is you multiply the numerator by the reciprocal of the denominator. Remember that? Well, look. They're the same. This will simplify. Sine A minus cosine A over sine A plus cosine A. Actually, what I probably should have done. No, that's fine. Multiply the numerator and the denominator by 1 over cosine of A. Or in other words, just divide every single term by a cosine of A. Sine over cosine is tangent. Cosine over cosine is 1. We're left with tangent A minus 1 over tangent of A plus 1. Tangent x minus sine x over sine cubed, we're going to show that that is equal to secant over 1 plus cosine. Let's start here. All right, so as a note, tangent. We know that is sine over cosine, right? But 1 over cosine is secant. So we can also write tangent as secant times sine. This means that the numerator has a sign common. So that should be a sign cubed in the denominator. So this is where we're at right now. Secant x minus 1 over sine squared. Sine squared. One minus cosine squared. Now 1 minus cosine squared. Difference of squares. Huh. Well, look what happens. If I factor secant x out of the numerator, we're going to be left with 1 minus 1 over secant, right? But isn't 1 over secant cosine? Now look, 1 over cosine in the numerator, 1 over cosine in the denominator. It's a common factor. And so we're left with secant over 1 plus cosine. Right, and this identity is now verified. This is taking forever to sync. There it is. All right. Cosine of A times cotangent of A minus sine of A times tangent of A all over cosecant of A minus secant of A going to verify that that is 1 plus sine of A times cosine of A. So what I want you to do is for the next 5 minutes, just try and work this out on your own. All right, then I'll come back in 5 minutes and we'll go over it. Okay, so let's see how we did. Let's write everything in terms of sines and cosines. Cotangent. Cosine over sine, right? Minus. Tangent is sine over cosine. Right, and then cosecant 1 over sine. And secant is 1 over cosine. Now let's simplify. And so when we simplify numerator and denominator, perform out the multiplication, we're going to have cosine cubed minus sine cubed over cosine minus sine. Right? There is a formula for the difference of cubes. Right? So if you have a cubed minus b cubed, that factors to a minus b times a squared plus a times b plus b squared. Right, we have a cosine minus sine over cosine minus sine. So here's what we're left with. Now, addition, right, is commutative and associative, right? Meaning the order doesn't matter and how we group it doesn't matter. So let's move this sine squared to the first term and then group sine squared plus cosine squared together. Sine squared plus cosine squared is 1. And so we're left with 1 plus, well, actually, I want to rewrite that. Not that it matters, but multiplication is also commutative. So just so it fits what we want, let's write it as sine times cosine. Right, so we have 1 plus sine A times cosine A. And so our identity is verified. Let's start on the left. Let's multiply by cosine over cosine. And let's see what that gets us. And I'm going to leave the denominator alone. No, I don't want to factor out the, sorry, not yet. That'll work. I'm going to add 0. So I'm going to add 1 and subtract 1. Remember, addition is commutative and associative. I'm going to group 1 and minus cosine squared together and move it out in front. And then what we're left with minus 1, rather. Right? This, oh wait, I still need the denominator. Right, I'm gonna right now add over here. This is now sine squared. Yeah, I'm not gonna have enough room if I write it there, so I'm gonna write it down here. And subtract out a sine theta, and then immediately add it back in. This one is one that's definitely easier to do from the right-hand side first. Now, factor by grouping. right? We now have a common term. Left with sine of theta plus 1. Those terms will cancel rather. And we get sine theta plus 1 over cosine theta, which is what we wanted. Oh, there we go. Okay, so let's look here. This time I actually am going to start on the right-hand side, which is something I don't usually do. Multiply numerator and denominator by tangent minus secant plus 1. That should be a minus. There we go. Fixed. Yeah, I'm going to do that on the next line. Right, just distribute the numerator then group tangent squared minus secant squared together. Now, if we go back and look at the Pythagorean identity for tangent and secant, tangent squared minus secant squared is going to give us -1. See that? Now, just a little bit of rearranging the terms in the numerator. And then we get the desired result. So the identity is verified. Are there any questions? Okay. I'm going to do something a little different this evening. I'm going to start our break now, but still come back at 7:50. So I'll give a 20-minute break this evening. I'm going to look through my sources, my textbooks that I have, and find more of these verification problems that we can work on for the second half of the meeting. All right, so we'll be back at 7:50 to look at some more problems. Welcome back. So we're going to look at several more problems on verifying identities. Right? We're just going to go as long as we can. So let's start. By verifying this. Remember, cotangent is cosine over sine, right? Now, with absolute values, what we're allowed to do is split it across multiplication and division. Right, and remember, I'm going to need to move this down. So if you take the natural log of a quotient, it's the difference of the logs. Right, and then what we see, we have log cosine minus log cosine. They're gone. Then we have minus negative log sine. Right, and so we get log of absolute value of sine as desired. So the identity is verified. Okay, let's look at this one. Let's start the right-hand side. So what I'm going to do is write this as a plus and treat this as a -1 coefficient, right? So what winds up happening is this tangent of t gets raised to the -1 power. Okay, can you excuse me for a minute? Sorry about that. Right. So what we did was we took this minus, right, treated it as -1 coefficient. So it becomes plus the natural log of the tangent raised to the minus first power. Keep in mind, right, this does not mean it's the inverse tangent function, right? This is the reciprocal of tangent. But isn't the reciprocal of tangent the cotangent? And so we get 2 log of cotangent as desired. So log of secant plus tangent is equal to negative log of secant minus tangent. All right, so let's start with the right-hand side. And let's do this. And so let's multiply the secant plus tangent by 1, right? So we're going to multiply by secant minus tangent over secant minus tangent. Let's see what this gets us. Right? The numerator is a difference of squares, isn't it? Well, if we go back to the Pythagorean identities, we see that secant squared minus tangent squared is 1. We can write that as the quantity of secant minus tangent, right, raised to the minus 1 power. And then using laws of logarithms, Yeah, okay. Give me a minute. Sorry, I lost connectivity on my other device. All right, so when I looked up, I saw that it dropped right here. Right, so what I did, right, is I wrote, we can write this as secant minus tangent all raised to the minus first power, right? And then laws of logarithms. We can pull that exponent, -1, out as a constant multiple, which verifies the identity. Okay, so this one I'm going to leave as an exercise for you to do because it's very similar to what we just did. Let's look at this one next, I guess. Okay. Since addition, excuse me, since addition is commutative and associative, right? How we write it doesn't matter, and how we group it doesn't matter. So the order doesn't matter, and the grouping doesn't matter. So let's look at those two first. But cosine times secant, isn't that 1? What does log of 1 equal? Huh? So what does log of 1 equal? Isn't it 0? All right. Oops. And then this is like minus 1. So this is like plus negative 1 times log, right? And so we get log of cosecant. Right, which is what we wanted. And so start with the right-hand side. Right, we can combine these two. Right, as the log of their product. But remember, we saw earlier. Right, so we saw in the first segment that secant times sine is tangent. Now we can write this as cotangent times tangent, which is just 1. And of course, that does equal 0. This one is very straightforward. You take e to the log of something. Since it's an exponential base c and a logarithm base c, they will undo each other. And we're left with what we're taking the log of. And that is the Pythagorean identity, which is 1. This one is also fairly straightforward. So 100 is 10 squared. Right, and then properties of exponents allows us to just multiply the exponents, right? So we're taking 10 to a power, all raised to a power, so it's just those two powers being multiplied. Well, log base 10, right? And exponential base 10, so they undo each other. And we are left with 2 times sine of x. Any questions on those? Okay. So unfortunately, I'm going to call it there. Tried to fight through it for the entire period, but I can't anymore. I haven't been feeling well all day. So I'm just going to stop. As a reminder, we do not meet on Monday. You do have a test that's due at 6 p.m. on Monday, so don't forget that. And let's see what else we've got. The quiz. And then the 7th quiz is due before the start of our next meeting on Wednesday. So everyone, enjoy your extended weekend. Be safe. I will see everyone again next Wednesday evening at 6 p.m.